Hello everyone, my name is Rupali Tukaram Chogule. I am going to explain box cost transformation in data analysis. The subtitle is Transforming Data for Better Model Performance. First of all, what is the box cost transformation? The box cost transformation is a mathematical method used to transform non-normal dependent variable into a normal shape. This is very useful because many statistical techniques like regression, ANOVA assume that data is normally distributed. The transformation is parametric, meaning it uses a parameter lambda to adjust how the data is transferred. A power transformation technique is used to stabilize variance and make data more normally distributed. It is introduced by George Box and David Cox in 1964. Why use box cost transformation? Many statistical models assumes normality of residuals. It helps to reduce skewness, stabilize variance, improve linear relationships, enhance model performance in regression and ANOVA. The box cost transformation is mostly used to make the data more normally distributed, stabilize variance, improve model accuracy and interpretation, satisfy assumptions in regression and other statistical models. The box cost transformation technique is transform data particularly to make it more normally distributed or stabilize variance, often used in regression analysis and time series analysis. The box cost transformation is a statistical tool that transforms non-normal data into a normal distribution. This transformation can improve the accuracy of predictions mode using linear regression. There is three main reasons for using box cost transformation. First one is to stabilize the variance. In there, stabilizing variance is essential because it ensures that the result of statistical tests are not influenced by variability in data. Second one is too much variability can make it difficult to see patterns in the data. We can better understand what's happened our data set by stabilizing variance. Third one is to improve normality. Improving normality is also curricular because many statistical techniques assumes that the data is usually distributed. Here is box cost transformation formula. The formula is y lambda is equal to y raised to lambda minus 1 divided by lambda. If lambda is not equal to 0, in y, if lambda is equal to 0, minus lambda is the transformation parameter, minus y must be positive. Using this formula manually is a very laborious task. Thus, many popular libraries provide these functions. Lambda is the transformation parameter chosen to the best normalize the data. Y is the original data must be always positive. Choosing the lambda, use maximum likelihood estimation to find the best lambda. Common values in this: y is equal to 1, lambda is equal to 1, lambda is equal to 0, lambda is equal to 0.5, lambda is equal to 1 is no transformation, lambda is equal to 0 is log transformation, lambda is equal to 0.5 is square root transformation. Tools like Python, R, Excel can help. How to apply it in Python? Here is the one example of this. Data is equal to numpy dot array in bracket values. Transform data lambda value is equal to box cost in bracket data. Here is the example before and after. Before transformation, skewed distribution. After transformation, approximate normal distribution. Here is the limitations of box cost transformation. Work only for positive data, may not always achieve normality. Transformed data must be harder to interpret. Why normality is important in regression? Because in linear regression, residuals should be normally distributed. Periodical variable relationship should be linear. Error term should be have constant variance. Box cost helps us fix these problems when raw data doesn't meet the requirements. The real life applications for medical data, for example, skewed blood pressure values. Second is economics, for example, income levels. Third one is machine learning, before, for example, before feeding data into models. And last one is sales data, for example, numbers of units sold. Here is the conclusion of box cost transformation. Box cost transformation is useful for data pre-processing, makes data suitable for modeling, especially helpful in regression and machine learning, normalize data and stabilize variance, power function based on lambda, it must be strictly positive, transform data closer to normal, improves model performance and assumptions fit. The box cost transformation is most important to stabilizing the variance of data. Thank you.